Hello, I'm Erica Puentes. You are in QBA, and this video will be the second video on annuities. So the first video we discussed what an annuity is. We did some simple calculations for annuities, and it's a regular payment or a regular withdrawal of money. So we ended our last video on slide 19. You should have a copy of the handout, and we're going to continue with problem 9. You should have a copy of your formula sheet, and you can go through the PowerPoint presentation, which are all available on Blackboard. Let's refresh a little bit about annuities. This is the annuity handout that you should have already printed out and done the first half. We are now on question 9 right here. And I want you also to pull out let's go to the computer. This is your formula sheet. We are talking about annuities, and what we've talked about so far is ordinary annuities, or they're sometimes referred to as deferred annuities. The payment or the withdrawal is at the end of the period. For example, your car payment. It's due at the end of the month. If you buy the car on the 1st of the month, your payment's due the last day of the month. Same thing with your mortgage. You buy a house on the 1st of the month, your first payment's due at the end of the month. That is the definition of an ordinary or deferred annuity. And we will be using this first column right here where my cursor is circulating of ordinary annuities. Now I want to bring to your attention these first 3 formulas, future value, payment, and the number of payments, all have to have future value. The first one we're looking for future value. But this payment formula, we use this when the givens are future value. We use this to find the number of payments. We use this formula when we're looking for the number of payments given future value. These last 3 formulas are present value. This is the formula when we're given payment, we're looking for a present value. Here, we're looking for the payment given the present value. And the last formula, the number of payments, you use this formula when given present value. So these last 3 have to do with present value. When we talk present value, we're saying, well, let's, for example, you've been paying $1,000 rent for a couple of years and you know you can afford it. But you want to buy or purchase a house. Well, what house can you afford right today? So if we take the present value of $1,000, because we know you can afford that every month, over 30 years, we can find a present value or the cost of the house you can buy today. And that's exactly what the banks do to determine whether you qualify for the loan. In fact, you can go to the bank free of charge and say, you know what, I make this much money, I'm paying rent, this much rent, how much of a house can I afford? And they will actually give you a pre-approval. Just want to be sure you see this is your handout, annuities, and we're on question 9. And we're looking at present value. If you go through the book, we're about section 4.2. So let's jump over to my PowerPoints. And question 9. You plan to invest a certain amount of money at the end of each of 4 years in an account that pays 7% compounded annually. If the present value of the annuity is $338.72, what are the payments? So it's very important you write down the givens, because that will guide you into selecting the correct formula. I gave you the present value. I gave you I. I is 0.07 divided by 1 because it's annual. And payments are 4 times 1. We're looking for the payment, and I strongly recommend you write payment equals question mark. That's what you're looking for. You're looking for a formula with payment. Well, there's 2 formulas for payment. Here's a formula for payment, and here's one. How do we know which one to choose? I gave you present value, so this is the formula you use. Be careful. Make sure you don't forget about this negative exponent. So with payment with present value, you substitute it in, and you get $100 is my payment. Let's look at the same problem, but we have different unknowns and different givens. You plan to invest $100 in an account at the end of each year. The account pays 7% annually, and its present value is $338.72. How many payments must you make? Okay, so you're looking for N. I give you $100 as the payment. I is 0.07 divided by 1. And again, I give you the present value. There's 2 formulas to find the number of payments. There's this formula, but I have to give you future value. I did not. And then there's this formula where I give you the present value. I did give you the present value. So we picked the formula with present value. And I know these formulas are a little difficult to type into PowerPoint, but they are correct. When you type in the given information in your calculator, you'll get 4 payments. N equals 4. You always change that to years. Since it's annual, you divide by 1, and it's 4 years. This problem might not be on your handout. You can pause and write it down and then try it. You plan to invest $50 into an account semi-annual. The account pays 7% semi-annual, and is present value is $343.70. How many payments will you make? Well, this time our present value is $343.70. I is 7% divided by 2 because it's semi-annual. I said the payment was $50. You're looking for N. Here is the correct formula with present value given. Make sure you don't forget to put this negative sign, because this equation will give you a negative. A negative times a negative will give you a positive 8 payments. N equals 8. In fact, I think I'm going to type it in there. N equals 8. But you don't leave it like that. You've got to turn the payments into years, months, and days, if applicable. 8 divided by 2, it's 4 years. Now, interest, just like when we were given future value, when you're given the present value and you want to find the interest rate, it's by trial and error. And I believe I mentioned in the first video on annuities, you start at 5%, throw it in the formula, and see if we can get $338.72. When that doesn't work, you're a little bit off, go up to 6% and throw it into the formula, try to get $338.72, and then 7%. If I give you a test on this, I will make it easy. I am not going to give you an interest rate of like 5.23%. You will start at 5% and go up or down and quickly get the answer. Number 12, you plan to withdraw $5,000 from an account at the end of the next 7 years. The account pays 6% compounded annually. How much will you have to deposit at the start of the first year? Okay, write the givens and a timeline. So your payment is $5,000. Interest is 6% divided by 1 and is 7 times 1. And we're looking for the present value. You want to withdraw $5,000 at the end of the year. Maybe you're retiring. But what do you have to deposit today? So you're looking for a present value with a payment of $5,000, interest rate of 6% for 7 years. If I deposit $27,911.91 at 7% or 6%, pardon me, I can withdraw $5,000 every year. And that's how your 401k will work. Here's the problem. Wilson agrees to pay Smith $1,000 at the end of each year. So Wilson owes Smith money. If money is worth 7% compounded annually, what is the cash equivalent of the debt? So maybe he got an income tax return back and he wants to pay off the debt. So he's looking for the present value of the debt because he doesn't want to pay that interest, let's say. $1,000 at the end of 5 years. So 1,000 is our payment, 7%, and is 5. We substitute in the formula. And today I can give him $4,100.20, and I will pay off the debt. If he does not make any payments until the end of the 5 years, how much should he pay at that time? So now he's saying, you know what, I don't have any money. I'm not going to retire. I'll give you money from my 401k in 5 years when I retire. How much will it be worth then? So we're looking for a future value. He was supposed to pay $1,000 every year, but he didn't, at 7% for 5 years. So at the end of those 5 years, he owes him $5,750.74 because he did not make one single payment. Note here, here's a homework in the book. Please do the odd problems, and the answers are in the book for your reference. Section 4.3, we're looking for payments. What is the payment? You want to buy a vehicle costing $9,000. Your down payment, including trade-in, is $1,500. The remainder is to be paid in monthly installments over 4 years at 12% compounded monthly. Find the monthly payment. You write the givens. Okay? Interest is 12% divided by 12 because you're doing it monthly, or 0.01. How many total payments? Well, for 4 years times 12 months, you're going to make 48 payments. Your present value, I want to start getting into real life situations. You're buying a car for $9,000. However, you're turning in your old car and you're adding some cash, so you're paying down the principal by $1,500. So your loan is only $7,500, or your present value is $7,500. Substitute it in. Make sure, see this exponent? Make sure it's a negative and make sure there's parentheses around it. So therefore, your total payment is $197.50. So you're going to pay that 48 times. If I say to you, what's the interest? Well, I just said you're going to pay 48 times, you're going to pay $197.50. So out of your pocket, you're going to pay $9,480. Your total debt was only $7,500. So your interest is the difference between these two numbers. So the interest you paid, $1,980. And that interest is not tax deductible. Interest on cars is not tax deductible unless it is a company vehicle. Let's talk a little bit about a very common annuity, which is your mortgage. Question 15, you buy a home for $200,000 and you put 20% down. What is 20% down? That is your deposit. The bank wants you to put some of your money into this house. They want you to have some ownership of it, theoretically, and literally. So, you're going to get a 30-year mortgage at 12% monthly with monthly payments. What are those monthly payments? Mortgage is always compounded monthly. In our project, it will also. So, calculate I, N, present value again. 200,000 times 20% is $40,000. You're going to have to save up $40,000, and therefore our present value is $160,000. You bought a house for $200,000. You gave the bank $40,000, so your mortgage will only be $160,000, or your present value that you owe is $160,000. When you do your calculation for payment, it comes out to $1,645.78. That's a very high mortgage. Why is it high? Because this is an exaggerated interest rate, 12%. Today's interest rates are around 4 or 5%. Okay, so this is very high. However, it's easy to do the math when you're calculating I. That's why I did it. So let's, for example, you did make this payment. You made this payment of $1,645.78 for 360 months. So you paid out of pocket $592,480.80. That total debt or your mortgage was $160,000. So therefore, the total interest you paid was over $432,000. Again, this is highly exaggerated from the interest rate, but it's good for illustration purposes. Let's do the previous problem. But this time, how much will you owe after 9 years? Let's say after 9 years you want to sell the house and buy a bigger house. How much equity do you have in the house? So you're looking for, and this is very important, students all the time want to find future value, and that's incorrect. You were looking for the present value at 9 years. So, you've paid 9 years of payments, 9 times 12, or you've paid 108 payments, you owe 252 more payments. We're looking for the present value at 9 years. So we have our payment, we have I. What's difficult, and where people usually make the mistake, is finding N. We're looking for the present value at 9 years. We have 252 more payments to go. So the present value of the house is $151,169.33. We started owing, remember, $160,000. So even though we've made 108 payments of $1,645.78, we still owe over $151,000. Let's look at this. A 50-year-old woman deposits $200 at the end of each 3 months. Remember, 3 months is a quarter, until she's 65. And in the account pays 5% compounded quarterly. 3 months after her last deposit, she retires and she wants to withdraw equal amounts every 3 months for 15 years. What is the size of the withdrawals and total interest she earned? First, you want to find the future value. This is two separate problems. We're finding the future value of a deposits, of her 200 deposits, and then the second part of the problem is finding the payment, how much the withdrawals, the payment she's going to withdraw. So first, find the future value of her deposit given 4 times 15, because it's 4 times a year for 15 years. I is 5% divided by 4. The payment's $200. So her future value is $17,714.90. Now that's how much she will have at the end of 15 years. So now she retires. We're at 15 years. She wants to get payments. Again, I and N remain the same because she's going to do this for 15 years in a row. So she wants to know what her payment's going to be. She knows now this turns in to a present value because we're at 65 now. She's 65 years old. So her payment now for the next 15 years is $421.44. So let's summarize this. She gets $421.44 for 60 months. She's going to get $25,286.40. She put into it $200 for 60 months, or $12,000. So the interest she earned was $13,286.40. You might want to pause this to review that. That's quite and you might want to draw a timeline on that one. It would help. Okay, let's talk ordinary annuity. Last payment is partial. You want to accumulate $5,000 by making a $1,000 payment at the end of each year. If you get $5,000 compounded annually on your money, how many payments will you make and what will be the size of your last payment? So it's going to be partial. You're going to get a partial payment the last time. So we have our future value, we want $5,000. We have our payment of $100, and we have I. We don't have how many payments. We're looking for N. We're looking for N given future value. So if we calculate how many payments, it's 4.57 payments. So it's 4 whole payments of $1,000 we're going to get. But this decimal, this 0.57, means that last payment is going to be something less than $1,000. So I am going to get 4 full payments of $1,000 and then 1 partial payment, 1 payment less than $1,000. So that we're going to do this in 2 steps. The first part is we're going to find out what these 4 full payments are going to be worth at the end of 4 years. So here we are. We're going to find the future value of those full payments, those full $1,000 payments. In fact, I'm going to write it in here. $1,000 payments. The future value of those full $1,000 payments. So future value formula of the $1,000. So after 4 years, those 4 payments are going to be worth $4310.125. Now that last payment, we use the compound interest formula because there's no annuity involved. So the 4 $4,310.125 is now the present value. But we want to know what it's going to be worth at the end of the fifth payment. So we want to know the future value of those 4 full payments at the fifth payment. So we use our compound interest formula, 4310.125. It's going to be 5% for 1 year. So it's going to be worth $4,525.63. We want $5,000. So the difference between those two is $474.37. So we will have 4 full payments of $1,000, but that last payment, or the fifth payment, is only $474.37. I want you to pause this recording right now and take a look at this a little bit closer. It's not an easy concept to understand. Let's do another one. How many quarterly payments of $500 will it take to accumulate $5,000 if the rate is 5.5 compounded quarterly? What is the last partial payment? So I'll hint. There's going to be 4 full payments. There's going to be full payments and then a partial payment. So write down your givens. 500. Future value 5,000. I is 0.05 divided by 4. It's quarterly. We're looking for N. This time I gave you the future value. So therefore, we stick in our future value, find the for N formula that we have future value, and we plug it in, and we find that N is 9.43 payment. So we have 9 payments of $500. It's an annuity. So we want to find the future value of those 9 payments of $500. So in the future value formula, right here I'm circling, 500, 9 payments, the future value is $47.55.61. So this last partial payment, we use the compound interest formula. This future value now turns into the present value in the formula. 1 plus I raised to the 1, our last, and that equals 48.21. So the future value of those full $500 payments is 48.21. We subtract it from 5,000, and our last payment is 179. Our partial payment. So we have 9 full payments of $500, and then the last one is 179. 9 payments of $500 and 1 payment of 179. Let's do it given. Let's do a partial payment given the present value. You are left in an estate worth $50,000. Instead of receiving $50,000 in cash, you will get monthly payments of $1,000. A. The money is invested 6% compounded monthly. How many monthly payments will you receive, and what will be the last partial payment? Makes sense? Okay. So you're going to get more than 50 payments. 50,000 divided by 1,000 is 50, because it's going to generate interest. But how many? Well, we're looking for N. We want to know how many payments, but I gave you a present value. So we have to find N. We're given the present value of 50,000. We substitute it in, and we find out we will get 57.68 payments. So we say, oh, we're going to get 57 whole payments of $1,000. You are going to get 57 payments of $1,000 and then one payment less than $1,000. So let's find out what that present value is. Because I gave you the present value of the estate, you have to find the present value of those payments or the annuity. So the present value of those 57 payments is $49,490.31. The estate present value is $50,000. So you subtract that, and the present value, again, I emphasize the present value of the last payment is $509.69. That's the value of it today. However, you're not going to get it today. You are going to get it in 58 periods. So you have to take this and find its future value with the compound interest formula. And that last payment in 58 payments is going to be $680.67. So you're going to get 57 payments of $1,000, and your last payment is $680.67. If you draw a timeline, it will help you understand. And you're welcome to pause it. I'd like to do one more of it. A $100,000 loan is amortized, paid off with payments of $10,000 at the end of each year and a final concluding payment. Find the number of full payments in the amount of the concluding payment if the rate is 9% annually. So we are given $100,000 is the present value. 9%. Payment is $10,000. What is N? Okay, I gave you present value, so we're looking for the formula, N formula. We're looking for N, that present value is given. So here is the formula. We substitute $100,000 in for the present value, calculate it, and we got 26.72 annual payment. So we're going to get 26 payments of $10,000. So the present value of 26 $10,000 payments is $99,289.72. That's the present value. Okay? We owe, right here in present value, we owe $100,000. So I subtract these two. So the present value of that last payment is $710.28 approximately. But we're not getting this right now at present value. We are getting it in the future. We're getting it in 27 periods. Okay? So you take this dollar amount, use the compound interest for 27 payments, 27 periods. Our last payment is $7,276.87. Take some time. I recommend that you pause this and write a timeline. Now, let's go back. Annuities due, section 5.2. If we go to our formula sheet, we have been concentrating on these formulas in the left column, ordinary or deferred annuities, payment at the end of the period. Now I'd like to talk about annuities due. Annuities due is your life insurance policy. You have to pay it today in order to be insured for the rest of the year. Or your car insurance. You pay your car insurance today and you have insurance for a half a year. Or your rent. You pay it today, but you live there. So those are annuities due. And these are the formulas. So you have to be careful when reading a question, whether it says what type it is. we're going to talk about annuity due. In the previous example, the payment was due at the end of the payment period. Now it's going to be due at the beginning. Payment due is the beginning of the period. You put $100 in an account at the beginning of each of 4 years. The account pays 7% compounded annually. What is accumulated at the end of the 4th year? So write a timeline here like I did. So now we're putting the money here in the beginning of the period, and then at the end of the 4th year, we want to know the future value. So I will note future value, and I put this subdue here because it's an annuity due. I gave you the payment, I gave you I, and I gave you N. You substitute it in, and you're going to have $475.07. Please pause and make sure you can do these calculations. It's an annuity due because we put it in today. Let's find the future value of a deposit of $1,095 at the beginning of each year for 20 years, and we're 5% compounded annually. What is accumulated? Since the payment is the beginning of the period, you have to go to your annuities due formula. So givens, write your givens. You're looking for your future value, substitute it in, and you will have $38,1758. Now, just like deferred annuities, if you're looking for interest rate, you have to use trial and error. Now, I would like you to go and do the homework here on page 153. Now I'm giving the future value, and you're solving for the payment. Maybe you want to pay all your rent up front. Or you want to know what you owe in the future, and you want to know what the payment is. I apologize. So you go to your annuities due formula, given future value, substitute it in, and you find out your payment is $1,095. Let's do this same problem and solve for the number of periods. So I gave you the interest, I gave you the future value, and I gave you the payment. I'm looking for N. Make sure you choose the formula with that future value is given, substitute it in. Here it is, and there is the number of payments. Okay? These two are complex annuities. You can review them if you want. I'd like to end on this. I thought this was an adorable slide. That's what I feel like in my face-to-face class. But this concludes the introduction really to annuities, or Unit 5. This is the second video. The next video is we're going to concentrate on mortgages, which mortgages, as you know from my example, are in an annuity. However, mortgages are a special annuity. It's a common annuity, and I feel it's very important that students understand how mortgages operate, and you will have an Excel project on mortgages. So, good luck. You're welcome to contact me by email, and I will respond. Have a good day.